welcome to the first stumbling block in this class. So, there are going to be a number of these. For loops later on, function calls, how do variables work with function calls, but this one is the first one, and that has to do with reassignment, and it's because mathematicians have poisoned your mind to make you really believe that this has a single meaning and an absolute meaning. And we need to break you of that habit. And it might be painful, but that's okay. So, right here, I say that if I do this, I'll say A is equal to 5. And that's not really too controversial. If I say print A over here, assuming I can type, we get 5 as our value over here. Nothing too scary. So, and here, I read it as A is equal to 5, and that's generally the way you will read it and, say it. But really, again, this is the assignment operator. It is better to think of it as this kind of left arrow going this way. A gets the value of this. Now, why don't we do this? Because this is easily parsed as A is, as the expression, A is less than -5. So that won't work. And adding 2 more arrows won't help the matter. Or changing this arrow to a less than or equal to sign. Some languages have used what has been noted as the walrus operator. The walrus operator. To do assignment. To emphasize that it is not, in fact, equals. In fact, Google's Go language still uses this operator today for a very interesting statement. It's really cool. But honestly, we're lazy, so we just simply say A is equal to 5 because that's close enough. A is assigned the value of 5. So that's not really hard. Why is this a stumbling block, Professor Rosen? This does not seem too hard. You seem like you're just scaring us for no reason. All right? So let's go ahead and say B is equal to A. Okay? So now, let's go ahead and print B. And the value should be 5. Okay? Now, this is because in mathematics, you say, oh, B is equal to A. That means that B and A are essentially the same thing. I could write A anywhere I find B, and B anywhere I could find A, right? These two things are permanently bonded together. They are inseparable. They are the same thing, and that is inseparable. But that is not the way this works in Python, or in fact in any programming language. The way this works in programming with the assignment statement, remember this is assignment, is that we've got a box here labeled A, and I'm going to put this value into this box. It might be easier right now to thinking of copying this value and putting that copy into the box, because same over here, we're going to take the value inside A and put it into the box B, or a copy of that value in A and put it into box B. Point is that A is not going to be empty. It's not an empty box. A still has the value 5. B now has the value 5, right? Let's go ahead and emphasize that fact by moving our print statement down here. Okay. Now, here's the kicker. If I say A is equal to 7, right? In mathematics, because if we were thinking of this in terms of mathematics, you might go, okay, well, B and A are both equal to 7. A is equal to 7 and B is equal to A, so now B is 7? But that's not the way it works, right? 5 gets stored in A gets evaluated to 5, that gets stored in B, 7 gets evaluated and stored in A. So we have 5 stored in B and 7 stored in A. So we get 7 and 5. This is the assignment statement, not the equality statement. The textbook has an excellent animation of how this works out. But essentially here we are putting things into boxes. The issue here is that if you're thinking in terms of mathematics, you might be thinking that these things are permanently bonded.